Hey everybody, welcome to Workflow of the Week or WoW Update. So what we're talking about right now is the solution that we found to our infrastructure problems. If you've been following along, we ran into a number of different issues in the way that we were dealing with things. Our Kubernetes cluster and other things were having these massive data spikes and huge CPU drop-offs and things like that. So the thing that we've actually found is that the way our Ceph cluster is working is it wasn't prioritizing user data over being able to transfer. So every time I would have a ton of different Docker containers that are all hitting the Ceph cluster very quickly, all at the same time, it would go, oh, cool, I got to replicate this all over. And then it would start looking like it was sending tons of data because it was sending tons of data because every single time it would copy into multiple places at the same time because that's the way Ceph works. Ceph is a distributed file storage system, and its entire goal is to make sure that it's immediately replicated into another location. So the big problem with that, when you have tons of little file writes, is that each and every one of those little micro file writes would then go ahead and send to not just one server, but at least three servers. So you'd see tons and tons and tons of data being transferred around. The big problem, obviously, with that is you don't really need that immediately for all these little micro writes. You could have it on one and then save locally and then send that off. So what we've done is we prioritized the writing until the user data was down, and then what that does is actually balloons the RAM. So it sits inside of RAM and holds it into storage and then saves it down as quickly as it can and then moves things off. So it ends up limiting the amount of data that's transferred to about 40 megabytes per second, which isn't massive. It's also not tiny, but at the same time, it also allows us to go ahead and do these workloads in a much faster fashion. And it also prioritizes, because the way that you can do it is you can do it in class tiered for data. We have tons of RAM. Underneath that, we have tons of very fast SSD storage. And then underneath that, actually, it's NVMe storage. And then underneath that, we have SSD. And then underneath that, we have spinning ROS, so big hard drives and things like that. And so what we've done is I've reclassified the way that prioritization works. And so it automatically goes and tries to save as much in RAM until it needs to go ahead and flush and then continues down, 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 down. And actually, the way that it starts sending it around stays in RAM in the first place and then continues down as it goes ahead and does that. And so this is one of those fun things that you talk about tuning and tuning for your workloads. And so what we've done is we've prioritized making sure that the end user's experience is the best as things go on. So everybody go to modtechlabs.com, sign up for one of our wonderful accounts, and of course, have a wonderful day.